Alright, so the next part, we're going to graph our probability distribution, and along the sides we're going to put the probability. Along the bottom we will put the random variable, whatever that may be. So in this case we'll have 0, 1, 2, 3, and then over here we'll have 1/8, 2/8, 3/8. And so let's graph these so that the height is the probability, and we have nice little evenly spaced squares. Hopefully this is the right size. Drawing it by hand, not so much, but we have our graph of our probability distribution. Alright, so now we're going to do, with our table, we're going to do mean, variance, standard deviation, expected value. So the mean is given by mu is the sum of the random variable times its corresponding probability. So for this example, our mean would be 0 times 1/8 plus 1 times 3/8 plus 2 times 3/8 plus 3 times 1/8, which gives us, that one goes away, common denominator of 8. We get 3 plus 6 plus 3, which is 12/8. So mu is, 12/8 is, 4 goes into both of those, 3/2. So 1.5 for our mean. Okay, now the variance is given by the formula sigma squared, sum of the x squareds times its corresponding probability minus the mean squared. Okay, so for our problem here we have 0 squared times 1/8 plus 1 squared times 3/8 plus 2 squared times 3/8 plus 3 squared times 1/8, then minus, now I'm going to use this number here instead of the decimal version, 3/2 squared. So this would give us, that one's not there, we'd get 3/8 plus 4 times 3 is 12/8 plus 9/8 minus 9/4. Get a common denominator, so we'd have 3 plus 12 plus 9 minus 18/8, which is 6/8 or 3/4. So that would give us a variance of 0.8 when we round it off to one decimal place because the data is integers. So our standard deviation then, square root of 3/4, which would be 0.9. Alright, the last thing, expected value. The expected value of our random variable is given by the formula random variable, sum of the random variable times its probability. And if you'll notice, that's exactly the same as the mean, so our expected value and the mean are the same thing. So the expected value for our problem is 1.5, because that's what we got.